Okay, it reads. Uh, smallest difference. Okay. Oh, at least I have. We can't hear you on my recording, but at least we have captions. So close enough. We can read you. Yes. Smallest difference. Write a function that takes in two non-empty arrays of integers, finds the pair of numbers, one from each array, whose absolute difference is closest to 0, and returns an array containing these two numbers, with the numbers from the first array of the first position. Note the absolute difference of two integers is the difference between them on the real number line. Oh, wait. For example, the absolute difference of -5 and 5 is 10, and the absolute difference of -5 and -4 is 1. Of course, you can assume there will only be one pair of numbers with the smallest difference. I understand. The one that's 2 is the one that's better. Yay! Do I have any ideas? Is that a rhetorical question so you can tell me the answer, or um so are we only using one pointer or two? Aha. Interesting. What do you mean the method of the algorithm? Like how we're gonna solve it? Okay. Uh, you can do a brief walkthrough of the pointer system. I agree. No. Absolute is was 129. Right. Well, you would compare the numbers to each other, and whichever one is smaller, that array needs to move its pointer. Right. Right. Because whatever the reason you said earlier. No. No, because 3 is still smaller than 15, so we still need a bigger number than 3 to get a difference. What you mean? Wait, what am I explaining? What are you asking me to explain? I understand, but I don't understand what I'm answering. why we still don't move array 2 or why we move array 1 or both. um, we're moving the pointer 1 again. That's what I'm trying to say. Yes. 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 Because we're looking for the smallest number, and moving 15 would just give us a bigger number. That's what I was trying to say. I understood. I was so confused. Okay. Which one's better? Um, I know. Wait, what do you mean? Which one is better? Like, which difference is better? Yes. We need to update. We need to update. Exactly. So our x1. I keep losing my space. So wait, our 12, 15. So our x1 should be moving. Our x1 should be moving. Based on the numbers, I don't know. Whatever the next one is. Wait, where's my editor? I'm like looking at your screen, but I can't see the whole thing. So like, where's my editor? Oh, so much has been typed. Yes. Yes. I'm not taking a nap. I'm not taking a nap. It's still the same. Wait, if x1 is 5, and why would it should still be, 15? I'm like, I know how to solve it, but I'm like, wait, where are we now? I keep losing track of which number we're on. The 10 minus 12 is the better one. So, what do you mean? As far as current absolute versus the new absolute? Yeah. So we should, because 10 is smaller than 12. Yes. The 5. I mean, I was just gonna let you go until you felt satisfied with the answer. There's no difference. Yes. Yes. We don't have to, but we'll figure it out. Uh, we can just. Right. Oh, we don't have to, by the way. We probably won't have to. No, we don't need to update it. Finally. We have to finally move uh, X2, Y1, whatever it is. We have to move that pointer. Right. Three is better. It's still 20, if I remember correctly. It should be 26. Three is better. Wait. Yeah, right. I'm like, wait, which one had three? Yeah, we do not update. update for the last time. We update. I'm so happy. To move the Y pointer. Right. We need a number bigger than 26. Right. I concur. Wait. Uh, wait. Where's 106? Oh, with two. if possible. It makes sense to me. You sound exhausted. We gonna write code now? You don't have to after that. Oh my goodness. Okay. Oh man. So are we pseudo coding or are we coding or so many steps? Exactly. think it matters. No no preference, I guess. Yes. Yes. Yeah. We should just stop the loop and just that's the answer. Yeah. Yeah, technically it's an edge case. Uh, I believe so. Ah, I hope I can remember. Like, 'cause I didn't do it, but as once I read it, I was like, oh, it's gonna be another pointer thing, so I should be okay. So now, I guess let's see. Uh, so first, no. He, oh my goodness, just do some jumping jacks or something. Okay. Okay, so we're gonna create a pointer 1 and pointer 2 variable and set that equal to 0. Oh wait, we also need to uh, do, 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 set sort both arrays. We'll just have const ascending equal function a minus b dot oh wait, not capital S, sort ASC sorry. Okay, there we go. That's so we sort both arrays. Yeah, I'm using like a lot of functions and variables. It's kind of easier. Where's our wallet? So, this is like an ES6 thing. As far it's like destructuring, where we basically create two variables, but we assign both of them to the value 0. But they each get their own. At least they should each get their own value of 0. That's why you declare it that way. Because if you said pointer 1 is equal to pointer 2 is equal to 0, then it doesn't keep track of them individually. This way, it's. Yes. It's just a shortcut. Uh, oh, right. And then a current abs. Oh, not a lat. It's a let. Well, it's not going to be equal to 0. I guess it's just going to be... whoa, what was that? Just have it empty for now. Yeah. Or actually... Actually, no. Instead of that, it should be... Array 1... Pointer 1. It should just Whatever, it should just be the initial value. It should be a number in the beginning. Yes. I'll have to do the absolute of that. Um, oh. Yeah. Uh-huh. Oh, not find. I meant, uh-huh. Uh-huh. That's it. Yeah. Yes. Uh, math.abs. Wait, is it? Oh, okay. I was like, why is there an error? I didn't spell it wrong. Okay. So, yeah, it's just going to be the initial value. And then we'll just compare from that. So, in my way, yes. I was like reading the comments and I was like, wait, are we starting the while loop now? And I was like, wait. Or, oh, actually, current absolute should be inside the loop. I was thinking of. Wait. Yeah, I was thinking of. I don't. What did you name the one that we're gonna return? Because one is gonna be outside the loop and one is gonna be inside the loop. The one I wrote is supposed to be the one outside the loop, but I forget what you named that one. Yes. Wait. Yes. We're gonna redefine them inside the loop. Okay, so what I was gonna do is, I was going to do. Oh yes, idea. So wait, the solution you saw had two while loops? Okay, that's what I was doing. I saw like, wait, what? So, okay, so, um, because I was gonna do my solution and then I would show like, because like the interviewer asked for my solution and then he asked like, how would you do it in production, where it's like where you write it how you would write it if it was like going to be like pushed into the final code base, I guess. So we're just gonna like try to solve it, and then I would like rewrite it. Yes. Uh, was it and or? Is 2 is less than. Oh wait, it's array 1 and array 2. I'm like, something's not right. Okay. Alright, alright. That's not right either. There we go. Equals. Aye. We just do that, make it readable. Yes. Because if yeah, so as long as the indexes are smaller than the length of the array, because the second they are, we want to exit the loop. Yes. So we do that. That's fine. Da 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 da. Oh, I guess. Yeah. So I guess we'll move all that in there. Oh wait, and we also need equal. Yes. So, okay. So now we got most of that set up. So now we're going to have a bunch of decisions as far as whether or not to move the pointer. So basically, we're making sure, because index 1 and index 2 start at 0, we only want to run the loop while index 1 is less than the length of the array and index 2 is less than the length of the array. So in your example, each array has 1, 2, 3, 4, 5, 6. Each array has 6 elements, right? In this example of the array. So we're going to start from 0, and we're going to go index 0, 1, 2, 3, 4, 5. The second we get to index being equal to 6, that means there are no more elements left in the array to search through. Because the array is sorted, the array is sorted from least to greatest, basically that means to find a smaller number, we need a bigger number than this array actually has. So there's no more point in searching. So we should exit the loop. Yes. So they both have to be less. Because if one of them is less, because if one of them is already at the end of the loop, then there's no reason to keep searching through the other array either, because it's only going to get bigger. So both of these have to be true. Otherwise, break out of the loop and return the best answer we have. I hope it was okay. It's indenting me so weird. Okay, if... So first we want to check if... Oh, wait. Since we're in our while loops, we can create variables. Because the variables are going to create every loop. Why does it... So const... And we could do const because it's just going to get overwritten. So const... Yeah, so here's current number. It's going to equal basically this. And each time we run the loop, it'll recalculate whatever this is. So current... Sorry, what? Oh, this should be named something else, actually. I don't know what to name it. I guess, smallest abs, I guess. Yeah. Yes. Yeah. Like... Yeah, I'll show you how to, like... We'll fix this, like, later. I guess maybe after we know it works. Maybe before. I just want to finish. So, okay. So if... First, if current abs is equal to 0, then well, basically we're done. So if the current abs is done, then like forget everything. We can just yeah. We'll use the result variable. No variables left behind. We'll just we'll do it like, yeah, we'll do, we can do push in this. What? No, we can't do push because we only want to return one set, and we're gonna have to replace the set every time. So no, we just have to, that's why it's a let, because we have to reassign it. Yes. So we would just assign that and then just return. We could also just return a completely, just a completely different array, but I figure we have the result array there. We could just use it and then return result. And then return exits the entire function, so that would be our answer. So best case, we search for that first. I just do a bunch of if statements because it's just easier for me to read than a bunch of else if, else if, else if. But it doesn't quite matter. So next, if, oh wait, why am I doing that? Current apps is less than. Yeah, in my case, we're going to like best case scenario to worst. But if current apps is less than small list apps, then yeah. Yeah. Wait, yeah. Yeah, I forget which order is which, but sorry, nope. It's smallest abs is equal to current abs. And then we update our result to the new smallest set. It's basically just going to be a bunch of if statements. It's going to be so awful in the beginning. So next we're going to check if Alright, these should be variable. This is official. I should have made these variables. So we're gonna do that. Let's have this. What did you call it? X1 and Y1? Let's do that, I guess. This is becoming too much to type. And for include a number where? We can use numbers. The number just can't start with a number. Yeah, it can't be 1x and 1y. It could be x1 and y1. So we're already doing some refactoring. Goodness gracious, that's so much. That's y1. That's already easier on my eyes. Y1. Okay. So now just check if x1 is less than y1, then basically x1 is with index 1. It should really be 2. Anyway, but yeah. Yes. Oh wait, that's not what I meant. Yeah. So then we'll just compare. If it's less than, then IDX2 plus plus. In this case, no, because it's only one line. Because it's one line, you don't need the curly brace. And because there's a new line, it only reads this. So it's the same as a curly brace. But if you wanted to like start combining stuff and trying to do and, it won't work. So then you would need the brackets. We could also use a ternary, but I'm not trying to use ternaries right now. Yeah, this technically reads better. Well, I'm using Option and the arrow key, by the way, to like randomly just move all this stuff up and down. Just do. Is the perfect number. And this will go all the way up to, yeah. Okay. Actually, we don't even need this return result here. Instead, we can just break. You know what break does? Okay. Yeah, this is just don't do any more loops. And then we return the result. Oh, this is a duplicate line, so I can remove that. Yes, this is it should be yes, I have to look at the colors. This is the end of the loop, and this is the end of the function. That's where we return the result. Yeah, we just break out of it, just say stop the loop, we're done here, we got what we need, and then return result. Yes. Yeah, because returns all the way, returns everything within that block scope. So it stops the function and returns the result. Break only breaks out of the loop because it finds the loop we're in. It breaks out of that one, and then we continue with all our instructions after the loop. And our only instruction after the loop is to return the result. So this, I can't think of anything else, so yeah, I say we should run it. This, let me see if you can run it. Run it. Oh no. 0 of 10k. Oh dear. What's the raw output say? 0 is not iterable. Wait, 0 is not iterable. That's what I'm thinking. I'm like, it's not iterable? Should I just declare them, unhighlight it? Should I just declare them normally? That's what I'm saying. Can you unhighlight it? So I can edit it. I mean, in the editor. Yeah, I didn't. First, let me just. Oh, wait, no, fix this. The other way would be that. But. Wait, did I? Yeah. That's the other way. I was like, I thought I could just shortcut it like that, but it won't let me. Let me just copy that. Okay. Yeah, because again, it's still just destructuring. Did you? Oh, did you run it? I gotta open Algo Expert. Wow, so that was really the issue. Yeah. So yeah, that's just a quick one. Okay. Yeah, I don't actually know the big O for this. So that should be interesting. So basically, we have each line. This is our basically our the sorting function. So instead of writing an anonymous function twice, we just pass in ascending, and this will sort our array in ascending order. That's all that is. So we sort both arrays. We set index 1 and 2 equal to 0, and we create an empty array with the result. We take our smallest absolute value, and we set that equal to basically the first two numbers in each, or the first number in each array. We get the first number in each array, calculate that, and then start have that as our smallest absolute in the beginning. Technically, we could also just, since we're already comparing these, we could also just technically IDX 1 plus plus, but I won't do that. It's already working. So that way we have one less number to skip. But I guess I'll write it. You don't have to, but since we're already comparing, when we start our while loop, we're going to compare. Actually, no, we will leave it at there. I'll take that back. Because we still have to compare all this stuff. It would be outside the loop, so technically my idea was like, oh, we could just skip and then compare all the other numbers. But we don't, but no, we still need to do the while loop. So I just left that out. So we compare if each, we run this loop as long as neither index is greater than, as long as the index is less than the array length, we're going to keep running the loop. So while that loop runs. Sure. Yeah, as long as both index numbers are smaller than the length of the array. Yes. Right. Yes, because if nothing matches, there's no result. Oh well, there's gonna be a match eventually, but actually, yeah, technically it'll never be an empty array. Technically, it'll be some. Even if the number's awfully high, it'll return something. Or even if it's just like one element in each array, it'll just return that. As long as the array has one element, the result will be something. So technically, this could even be like just index 0, technically, but just to start off with. But we don't need to really, I guess, worry about that. So inside our while loop, we're just declaring our variables just to make it easier. And these variables will get, the values will get reassigned each iteration of the loop. Here we check if our absolute value is equal to 0, in which case we found the absolute best possible match, and then we break out of our loop and return the result, which is this. Okay. Oh, sorry. Yes. Next, we're going to check if current absolute value is smaller than the overall smallest absolute value that we have.
And if it is, then, you know, if it's equal, then none of this runs. But if it's not equal, then we check for the next best solution, which is that our current absolute value is smaller than our current smallest absolute value. And if it is, then we reset our smallest absolute value to equal our current smallest absolute value. And because our our and because we found the new smallest absolute value, we uh, change our result to equal the value of index 1, or the value of the current array that we're on, and the value. I don't know how to write that. Basically, we return both of the values that we were comparing. Whatever values that we compared that gave us smallest absolute, we put that into our result array. Yes. And then again, if if the value in array 1 is smaller than the value of array 2, that means we need a bigger number from array 1, so we increase that index. And then we basically run the same check in reverse. And if, and because this check passes, this check will fail, so we don't have to, if this one fails, this one passes. If this one passes, this one fails. So they're never gonna like conflict with each other, because the index won't increase until the loop is finished. So once we get down here, then there's no other steps left. Then whichever one of these passed, we increase the index, and then jump back up to our array, or to our while loop, and then run everything again. So if current abs is greater, we don't do anything basically. If it's equal, we don't change it. If it's greater, we don't change it. But whether it's greater or equal, we still run the bottom two. Because these are just if statements. It's not if else or else. So each if statement is going to run no matter what. These two will run no matter what, because these if statements do not depend on this if statement. None of the if statements depend on each other. They're each going to run independently. Yes. Yes. This is only comparing what's in this block. So if this is true, then we proceed with the rest of the steps. If it's not true, then we just ignore this entire block and move on to our next conditional. If we moved that to the bottom, it would still work. It would still work because if you know how plus plus and minus minus work, when the plus plus is at the end, it won't change the index until the loop ends. So like our current absolute value and everything won't change. I mean, the order in which they run will not affect whether the function works. So these two will run first, but these two do not affect whether or not this runs. These two do not affect the answer of this. The only if statement that affects anything is our first case, where if it's equal, we stop everything and just return an answer. But other than that, none of the if statements depend on each other. They all run independent. So if you moved it to the bottom, it would still work, or it should still work. Correct. Did you copy the right thing? Let me check mine. Maybe it shouldn't, but let's see. Yeah, it still works for me. Yeah, I just moved it on my end, and it still works. What do you mean is the common practice for the as for? Um, I mean technically it doesn't matter, but as far as what I've seen, you always update the pointers last because that's like just kind of convention. Like when you run a for loop, the last step is I plus plus because in our mind we understand that once everything is done in the loop that we need to do, now we update the pointers because it's the safest time to update the pointers. However you like to update your pointers, it's the safest time is after you've checked everything else. Hmm. We're sorting to arrays. I say we're sorting to arrays. Sorting is n log n, so sorting 2 is 2n log n. Uh, and then we have a while loop that basically iterates over each element in the array, potentially. Um, we have some variables. So I would say that's n log n, that's n log n, and then the while loop. So I would say it's n log n. Oh, yeah, it's n log n. Oh, n log n plus m log n. Okay. Yeah, that makes sense. Um, so n log n is the sorting of the array, because we have to compare each element of the array to each other. But in our while loop, we don't, because it's already sorted, we don't have to compare each element of the array to each other. We can, we almost never have to. We basically, it's almost worst case would probably be 2n. Not 2n, but or m, but basically we only have to search until one of these arrays is completely finished. Usually, it's going to be rare when we search through both. So I'm trying to think of how to explain it. Because n is the length of the array for the sorting algorithms, but m is like the length of both arrays. And yeah, I'm not sure how to explain it. It makes sense because the time complexity to sort the arrays and the time complexity to compare both arrays are similar but slightly different, because we have to compare each element. We potentially have to compare each element to multiple other elements, but m should be smaller than m log m should be smaller than n log n. But I can't really explain it. I have to watch the video on that. Is that what the video said? I was laughing. I'm looking at this solution. I'm like, oh my goodness, he used infinity. That's great. I can't remember. I don't think I've ever used infinity in code before. That's amazing. But I have to see the video. I'm not entirely sure. Mm. We created some extra variables, but the creation of those variables is constant. It's always, each variable is always going to, contain what its value isn't going to grow or shrink. Result is always going to be an array of 2. Index 1, index 2, small, our current abs, our smallest abs, they're all just going to hold like a number value. So like the size of those in storage, the size of those variables is never going to change. I am going to stop recording now. Great recording. I don't think they heard you at all.